Welcome to NextGen Manufacturing Nexus. Today, we're diving into a technology that's literally creating a living, breathing blueprint of the entire factory floor. And let me tell you, this isn't just some small improvement. It's a total game changer for how we build, well, everything.
But before we get into that, let me ask you a question. What do you think is the single biggest, most expensive threat to a modern factory? It's not what you might think. It's not supply chain hiccups. It's not labor shortages. Nope, it's something way more fundamental. The answer is this number right here, $1.4 trillion. That is the insane annual cost of unplanned downtime for the world's biggest companies. It's like a quiet catastrophe that's happening every single day, right under our noses. And that massive number brings us right here to the high-stakes world of the factory floor. This is the arena where that quiet catastrophe plays out, a place where every single second counts and every stoppage costs an absolute fortune. I mean, think about it for a second. A single hour of downtime for a car company can cost over $2 million. For decades, the battle against this enemy has been completely reactive. A machine breaks, the line grinds to a halt, alarms start blaring. The Holy Grail has always been to see this coming, to prevent the chaos before it even starts. So, to break out of this endless cycle of putting out fires, the industry is turning to something called the digital twin. Now, you've probably heard the term thrown around, but we need to get really specific here because it's so much more than just a fancy 3D model. In fact, thinking they're the same thing is one of the biggest misconceptions out there. A static CAD model? That's just the blueprint. It's not a living, breathing thing. So what really separates a true digital twin from the rest? Well, it all comes down to the data flow. A digital model is totally static. You have to update it by hand. A digital shadow is a step up. It automatically pulls in data from the physical world. But a true digital twin, this is the key. It creates a constant, two-way, automatic data loop. It doesn't just listen, it talks back. And this is also what makes it totally different from a simulation. You see, a simulation is built to answer what if. What if we tweak this part? What if we run the machine 20% faster? It's all about exploring hypothetical futures. A digital twin, on the other hand, asks, what is? It's a persistent, evolving mirror of what's happening in the real world, right now. So this definition is really the crucial point. A digital twin is a dynamic virtual replica, constantly being fed real-time data from IoT sensors, which creates a living, evolving model. It's not a static picture, it's more like a live video feed with a brain. Okay, so how does this living part actually work? Well, the magic is all in the feedback loop, this constant conversation between the physical world and the digital one. Let's just trace this flow for a second. It starts with sensors on the actual machine collecting raw data, temperature, vibration, output, all that stuff. That data gets streamed to the virtual model. The twin then analyzes it and runs constant little micro simulations to predict what's going to happen next. And here's the crucial final step. The twin sends insights, or even automated commands, back to the physical machine, closing the loop and optimizing its performance on the fly. What you get is this incredible symbiotic relationship. The virtual world isn't just watching, it's actively making the physical world better. The real machine gets smarter because of its twin, and the twin gets more and more accurate because of its real-world counterpart. They learn from each other. So that's the theory, and it sounds pretty cool, right? But what does this revolution actually look like in the real world? Well, the results are already here, and honestly, they're pretty mind-blowing. Just take a look at Siemens electronics plant in Amberg, Germany. By creating a super detailed digital twin of their entire operation, they boosted productivity by 20%. And even crazier, they increased their ability to adjust manufacturing volume by 30%. That means they can react to what the market wants way faster than before. That's a huge competitive advantage. And look, this isn't just some niche tool for the giants. According to Gartner, while about 13% of companies with IoT projects are already using digital twins, a massive 62% more are in the process of putting them in place. This isn't some trend on the horizon. This is the wave that's happening right now. And the benefits directly attack that trillion-dollar downtime problem we started with. Predictive maintenance is the big one, fixing machines before they break. But it also means you can validate designs faster, slash material waste, and optimize your processes in real time. It all leads to smarter decisions top to bottom. But as powerful as all this is, it's really just the beginning.
The next evolution of the digital twin is pushing us toward a future that is way more autonomous. Right now, we're seeing AI integrated into these systems, creating twins that don't just predict problems, but can actually self-optimize a whole production line. In the very near future, we'll be interacting with these twins through augmented and virtual reality. And then, on the horizon, you have the industrial metaverse, entire virtual factories where engineers from all over the globe can work together in a shared digital space. I mean, just picture it for a second. An engineer puts on a pair of AR glasses, looks at a machine, and instantly sees its temperature, its stress levels, its entire maintenance history, all just floating there in front of them. Or imagine a team designing, testing, and even running a new production line, completely inside a virtual world, before a single physical bolt is ever turned. So let's bring it all home. The big takeaway is this. A digital twin isn't some static blueprint of what an engineer designed years ago. It's a living, breathing mirror of what is happening right now. And thanks to things like AI, it's a powerful predictive engine for what is going to happen next. It completely closes the loop between design, production, and operation. And that leaves us with one last kind of fascinating question to chew on. As these systems get smarter and more autonomous, are we going to reach a point where a product's digital twin, learning from all that real-world data, can actually design its own successor, creating a perfect, self-evolving product? Definitely something to think about.